Hello, everybody. So today I'm going to talk about lesson number one. We are dealing with the decimal system, binary system, octal system, and hexadecimal system. And then I'm going to convert from binary to decimal and vice versa. So let's talk about decimal system first. Decimal system is the one that we use every day, okay? It has 10 digits. All right, it gotta go from 0, 1, 2, 3, all the way to 9. So you got 10 digits. All right, and octal system, octal means 8, so it got 8 digits in its system. So you have 0, 1, 2, 3, all the way to 7. Okay, and then hexadecimal, that means 16 digits. This system has 0, 1, 2, 3, all the way to 9. That means 10 digits. So that we have to borrow ladder for next digits. So letter A, letter B, C, D, E, and F. So this system has 16 digits altogether. Now, this course we deal mostly with the binary system. So binary system has 2 digits, 0 and 1. 0 represents on and 1 represents off, close and open, and so on and so forth. Okay, so we're gonna talk about how you look at the base of 10 first, and then we're gonna work on binary. So let's say if you know that the base of 10, which is decimal number, it go from 0. Let's say it goes from 0, you can go 0 to 18 or 21 and so on and so far, So if 0, any power of 0 equal 1, all right? So 10 to the power of 0 equal 1, and 10 to the power of 2 or 10 square equal 100. 10 to the power of 3 equal 1,000. All right, and then you got 10 to the 4th equal 10,000. And then 10 to the 5 is 100,000. And 10 to the 6, 10 to the 6 got 6 zeros, so you got 1 million, all right? 1 million. All right, and most of you probably know all the way to 9 or 12. 9 is a billion, so I'm just write a billion for letter instead of writing down the number too long. And 10 to the 3 more, make it 12. If we got trillion, and then 10 to the 15 is quadrillion, and so on so far. You go to quadrillion, pentillion, sextillion, septillion, and so on so forth, octillion, all the way to higher. And another one that you just make known of this one, 10 to the power 100 is Google, all right? So Google is not the name of the engine search, not the search engine the website, but it's spelled Googol, Google. All right, 10 to the power 100. Okay, so what would happen if you got for example, you got 1,237, and this is a decimal number. Some people write out this one, it means the decimal number, and you want to expand it into power of base equal 10. So you have to expand it. So you know that it's gonna 1 multiply 1,000, so 1,000 go like that, plus 200 2 times 100 and plus 3 times 10 and plus 7 times 1. Okay, and or you can do based on the power of base of 10, so you write out 1,000 like that, or 200, you can go like that, and so on and so far, okay? Okay, so that's the way you write down, and then you add together equal, 1,000 plus 200 plus 30 and plus 7. All right, so if they want you to expand the number, decimal number into the expanded form, so you have to write in this way. Okay, so that's the way you do. What would happen if you have a negative number or decimal number? Let's say that you got, let's say, 321.28. So how are you going to do like that? Well, so you know going to be 300 plus 20 plus 1 plus 2 divided by 10 plus 8 divided by 100. All right, so you can write out in the power of at the base of 10, then you write out 3 times 100 plus 2 times 10 and plus 1 times 10 to the 0 plus 2, and with the base equal 10, but it's this decimal number, division should be, the exponent become negative 1, and then plus 8 times to negative 2. Okay, so when you have the exponent equal negative or the power equal negative, that means the division is a small number, the decimal number. Okay, so you already know how to write out in expanded form. The question right now is, are we going to do the same thing with the binary number, which is the base equal 2? Okay, so before we do like that, I'm going to explain to you first the equivalent decimal number for the power of 2. So let's look at this one. If you got power 2 to the power of equal 0 equal 1, any power of 0 equal 1, so you go all the ways to maybe 8. Okay, go power 2 of 1, 2 to the power of 1 equal 2, power to the 2 of 2 equal 4, 2 to the power of 3. Some people think about, let's look at this one, they think it 2 times 2 equal, 2 times 3 is equal 6. It's not. It's, you got multiply, not adding. So make sure they do 3 times like that. 2 times 2 equal 4, 4 times 2 equal 8, not 6. Or 4 times 2, one more equal 8. All right, and 2 to the 4, 8 times 2 equals 16. 16 times 2 equals 32, and so on and so far. All right, and 2 times 7, double of 64 equals 128, and double of 128 is equal 256. All right, 256. All right, so that's the way you look at the base power based on the base is a binary number. The number 2 is a base, and you can go all the way from 0 to 8. Okay, so the question is how you convert. No, let's look at this number first. If I got 1, 0, 1. All right, so how do I convert this one into decimal number? How I convert this one to the decimal number? All right, 101. So in order to do like that, I want you to look at the table. So in the book, it says that you look at the table and then you can do the conversion. Okay. But before we do, let's look the decimal number too, and we can deal with that when we get to decimal number. So I'm gonna show you the way we do horizontally, and rather than look up and down like this one. All right, so you got 2 to the power of 8 equal 256 all the way to 2 to the power of 0 equal 1. Okay, so let's say that if you have a binary number, I can just make it up. Let's say if I'm gonna do like this, 1, 0, 1, 1, and 1. And I wanna know what is the decimal equivalency for this number. All right, before I do, I'm gonna work from the right to the left. Instead of work from the left to the right, I work from the right to the left. So you put down the 1 in front of that. All right, so 2 to the power of 0, all right, equal 1, right? 1. And then next one should be power 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and 2 to the power of 4. All right. So you can multiply by 1, 0, 1, 1, 1, or I can look in the front. I can do like this and add together. 0, because this one's 0, multiply to the power of 3 plus 1 multiply 2 to the power of 4 plus 1 multiply 2 to the power of 1 and plus 1 multiply 2 to the power of 0. And we already know the decimal equivalent is right here, so I can just write out. So I just write out here 1, 2, 4, 8, and 16. All right. And now if I look at this one, I multiply by 8. And 0 multiplied by any number multiplied by 0 equals 0. So I don't have to worry about this one. All right. Don't add to that one because that equals 8. So what I do is I add all this number together. 16 plus 4 equals 20. 20 plus 2 equals 22. 22 plus 1 equals 23. So this is the way you write out how you convert from the decimal or from the binary to decimal number. Okay. They have another method by not just look at the decimal number, but look at the different method. We call double. All right, so let's look at another number by using the binary and convert that to decimal number using the double method. Not just look at the table, but double method. So let's look at one example. Maybe I'm gonna go over here. All right. So I'm gonna give another example. Let's say 1, 0, 1, 1, and 1. All right, I look at this binary number and then I'm gonna convert it to decimal system instead of using the table, which is you can do it by look up the table, but this method we call double. All right, so I'm gonna write down double. You double each one and then you double, that means you add in each one underneath of it. All right, so I start from the left to the right. I bring this one down, okay? I bring that one down. And each one I multiply by 2. So 1 times 2 equal 2. So I write out 2 on top over here. 1 times 2 equal 2. And then 2 add with 0 equal 2. So the second one is 2. You add together and you put underneath here. Now the next one I do double. So 2 times 2 equal 4. So I put down 4 on top here. I multiply, double the 2 equal 4. And 4 plus 1 equal 5. I put down 5 under here. All right, and then I double again. 5 times 2 equal 10. And 10 plus 1 equal 11. All right. And 11 double equal 22. And 22 plus 1 equal 23. So this is my final answer for double method. Okay. And we already know that 23, this one, well, if you want to check by look at the table again, you see this 1, and this one is 2, and this one is 4, and this one is 0, so you don't have to worry about this one. And this one is 16, because a times 0 equal 0, so don't have to worry about this one, 0. All right, so 16 plus 4 equal 20, 20 plus 2 equal 22, 22 plus 1 equal 23. So it works the same thing. Whatever method you are comfortable with, you can work on that one. Okay, one more method and then you're done. And then you just complete the lesson number 1 that I posted on in Canvas. So you can just turn it in, submit it in by September 6th, I believe. So let's look at another method. This one we call the division method. All right, division method. So I'm gonna look at give a different number, any number. Let's say, I can say number 23. Let's do number 23, same number. All right. All right, number 23. Now we have a decimal number, and I want to convert it to the binary number by using the division method. All right, so each one you have to divide, each time you divide by 2. All right, so you write out over here, so you got 23, and you divide by 2. All right, so each one you divide by 2, so divide by 2 equal 11, big 11, and you got remainder equal 1. 23 divided by 2 equal 11. 11, and then you keep dividing next round. So the 11 divided by 2 equal 5, right? And then you got 1 remainder. And 5 divided by 2. Anytime you have an odd number divided by 2, you have a remainder equal 1. So 5 divided by 2 equal 2, because 2 times 2 equal 4, and then 5 minus 4 equal 1. And then 2 divided by 2 equal 1, but the remainder is 0, because you don't have any left. 2 divided by 2 equals 0, right? I mean, equal 1, and then remainder equals 0. And then you keep dividing. 2 divided by 1, 1 divided by 2 equal 0. And the remainder equal 1. Okay? 1 divided by 2, you got 0. You cannot divide by 2 because small number, so remainder equal 1. So, and then you write out 1, and then you go counting from bottom up. So you write 1, 0, 1, 1, 1. And we already know this number is equal 23. Right here, 1, 0, 1, 1, 1. 1, 0, 1, 1, 1. So this division method is another way of looking. Okay, we're gonna do 2 more numbers here. I got 2 more numbers. This one, using this one, you can do by table or double. So I'm gonna do double. See what number here. 1, and I bring it out 1. 1 times 2 equal 2, and 2 plus 1 equal 3. And double 3 equals 6 plus 1 equals 7. Double 7 equals 14 plus 1 equals 15. 15 double equals 30. Add equals 30. 30 double equals 60. 60 plus 1, 61. And 61 double equal 122, and plus 1 equal 123. So that your answer is 123. All right, double. This is double. Double. All right, now if I'm going to use the same thing, 123, and I convert back to the binary, see if it's correct or not. Make sure that, okay, so 123, you put out 123 and divide by 2 equal 61, and remainder equal 1. 61 divided by 2 equal 30. You remainder equal 1. 30 divided by 2 equal 15. It's no remainder. 15 divided by 2 equal 7. And remainder 1. 7 divided by 2 equal 3. Remainder equal 1. 3 divided by 2 equal 1. Remainder equal 1. 1 divided by 2 equals 0. And remainder equal 1. So you bring it up from bottom up. So you're going to write down 1, 1, 1, 1, 0, 1, 1. Okay, so it's the same thing. 1, 1, 1, 1, 0, 1, 1. Okay, so this, try to be comfortable with the division method and double, and then do the exercise. And next week, when I do another video, we can talk about the decimal number and so on and so forth. All right, you guys have a good week and do the best you can to complete the first assignment. All right, so long for now.